Welcome to module 24 of Object Oriented Analysis and Design. From the last module, we have started discussing about different UML diagrams. Specifically, we have been talking about use case diagram, and we will continue on that. In the use case diagram, we have seen that there are few components that define the diagram. The actors in a use case diagram are responsible for starting use case actions or can be responding to some use cases as passive actors. We have seen different classification of actors. The second component are use cases, which are well defined perceived functionalities of the system that we want to put in place. So, these are the actions that the actors initiate. Every use case is described by a name, and we have seen that in the specification of the use case, we can state its purpose, precondition, postcondition, failure condition, optimal or most expected flow, and so on. In this module, we will discuss about relationships amongst use cases. There are three major relationships that exist between use cases. This is given in this outline, which will also be available on the left hand side of every slide. So, the relationship amongst use cases, there could be various kinds. When we talk about relationship, it is basically a dependency between two use cases. So, a relationship is, I have a use case here, I have another use case here, and I am putting some kind of a dependency between these use cases, and that dependency is known as a relationship. Defining the relationship between the two use cases is usually a decision that the person modeling the system would take. So, analyzing the specification, looking at different conditions that may exist between these actions, we will identify different relationships. Here, we will talk about three relationships: the include relationship, the extend relationship, and the generalization relationship. So, we will start with the include relationship. The include relationship involves one use case that involves another use case, that includes another use case. So, the include relationship basically explores the issue of reuse. So, if we just draw a parallel with the common programming paradigm, then include relationship is kind of one function calling another. So, when we want to perform some action, say main function wants to perform some action, and that includes printing certain values, then main would not be directly printing it, rather main will call a function printf to take care of the actual printing process. So, if main is one use case, then printf would be the other use case. So, that is a typical programmatic view, but in general we will say whenever we have a use case A and to complete its own functionality, it might need another use case B, then we will write it like this: A include B. So, you should note the direction of this relationship. A is the base use case which needs B, B is the included use case which we will assume is self contained. Of course, in turn B may include other use cases, that is quite possible. So, the arrow direction of the arrow would be from A to B, and the style of the arrow would be dashed. And to make it explicit that it is an include relationship, we will use a guillemot and say that this is an include. So, this is the way we write it. So, that would mean that the behavior of B is included in the behavior of A, because while the use case A is executing at certain point, it will invoke B and complete that. And the included use case B is necessary to ensure the functionality of the base case. So, without B, I cannot complete the functionality of A, and this is the basic notion of an include relationship. So, for example, if we have a calendar kind of an application where there are different appointments that I can insert, create. Now, certainly we will expect that once an appointment has been created, then there will be a notification given to the participants. So, one use case is the insert appointment, the other use case is notify participant, and there is a include relationship from the insert. So, insert appointment is the base case and notify participant is the included use case in. Now, we may note that like in functions which can be called from multiple functions, the notify participant, this use case notify participant may be included in other use cases. For example, if I later on somewhere I have another use case cancel appointment, then certainly when an appointment is cancelled, the participants need to be told. So, notify participants would also be included in the cancel appointment use case. Talking about our ongoing LMS system, we have for a leave we need to run a validation to check whether a particular leave is a valid one, and if we say that use case is validate leave, which has all the actions performed to validate a leave, then the include use this will be can be included whenever we are doing a request leave. So, when an employee is requesting for a leave, certainly before the requested leave can be created, we need to validate that the tentative leave record is a valid one. So, request leave is the base case and validate leave is the included case that will get included. Certainly, validate leave can be included also in other use cases like approve leave. When the lead goes on to approve a leave, naturally it will need to be checked that the leave being approved is a valid one under the conditions that the lead may have imposed on the leave. The second relationship between use cases is known as a extend relationship. Extend relationship is kind of a optional, adding an optional behavior among the use cases. So, it can be used to add some optional behavior to what has already been defined for a use case. Now, when you want to add this optional behavior, now this optional behavior means that it could actually depend on certain conditions. So, you can also say it is a conditional use case. So, the conditions are represented in terms of extension points. So, you see if you reach the specific extension point, then you invoke the extended use case. So, if we say we have a base use case A as in here, we have an extending use case B as in here, and in this case both A and B are self contained, unlike in include where B was self contained, but A the base case was partial because it needed B always. Here that is not the case, because this is a case of optional or conditional invocation, but A controls if B should be executed or not. That is a conditional one, that is a optional one. So, these are the couple of points we can note. The behavior of may be included, may be incorporated into A provided it is invoked. So, extending the use case B is optional, that is it may be, but it need not always be activated by A, and there are extension points that specify the location in the use case A where the extending use case will be used. So, there is the condition under which this is incorporated, the condition is actually given by the extension point. Now, some more details will include that more than one extension point can be specified for each use case. There could be multiple different conditions under which the same use case execute. The names of extension points must be unique, of course, otherwise we will not be able to identify them. And certainly, since one use case may extend multiple extension points, it is quite possible that the number of and names of extension points and the number of extended use cases may not be one to one. There could be multiplicity of relationship. So, as an example, say a savings bank account provides bonus if the deposited fund is above 20,000 or the depositor's age is above 60 years. Either the depositor is a senior citizen or the fund value is more than 20,000, then a bonus is provided. And if the use case for providing the bonus is calculate bonus and the use case of actually computing the fund is deposited fund amount, then we can have an extension point which incorporates these two conditions, the senior citizenship condition as in here and the fund level condition as in here, and we are showing those in the diagram. Let me just clean up and show you again. This is the extension point and the deposited fund amount is the base case, and this is the extended case that will get invoked at this extension point. That is the basic idea of extend relationship. So, in LMS we know that there are certain types of leave. We have seen certain different types of leave which can be approved provided there is certain conditions that will satisfy. For example, for a maternity leave, certainly the certification is required that the employee in question already has the medical condition of pregnancy, or for a sick leave we need the certification that the person was sick and doctor has checked and so on. Similarly, for a parental leave we will need the birth certificate of the baby that has been born to the associated employee. So, let us try to put that behavior of as a check report, which you may want to incorporate into the approved leave, which means if the lead has to approve a particular leave which is of either these are you remember the leave types, the ML, SL, ML is a maternity, SL is a sick leave and PL is a parental leave. If any of these leave have to be approved, then for those leave we will need to check for this, and certainly for the maternity and sick leave it is kind of medical report. So, I can have we can model an extended use case which is check medical report, which has to do all the necessary tasks for actually checking out the validity and authenticity of the medical report and so on. Whereas, for parental leave we need to check some corporation document, municipality document regarding the birth of the baby having taken place. So, that is another use case check birth report. So, we can model this by having an extension point or having actually multiple extension points. I should have marked them here. In the approved leave use case, one extension point is maternity leave, sick leave. So, in terms of approved leave, if the condition is that you have a situation of maternity or sickness, then the corresponding check medical report use case has to be invoked. So, that is designated by this arrow. So, here also note that the direction of the arrow is from the extend use case to the base use case, and on that again we put the Guillemot extend to mark that it is an extend relationship. On top we put the condition of extension, which is extension point name. So, the name of this extension point is maternity leave, sick leave. So, that name has to match here, maternity leave, sick leave, and then below that we try to mark what is the action that this extension will take, which in this case is verification of medical certificate. So, for example, for the other extension point, this is the other extension point where we have parental leave. So, the extend relationship will show what is the parental leave condition on which this check birth report has to be done, and here we specify as to what is the action that this will take. So, extension often is a very convenient way to relate different conditional use cases to one or more base use case. It is possible that the same extended use case may be associated with multiple different extension points in different base use cases as well. For example, checking medical report here is happening in terms of approval. It may need to be also invoked in case of say revoking a leave. You may really need to check on the report to actually decide whether the revocation can at all be permitted in the system or not. So, this was the second kind of relationship. The third kind of relationship that may exist between use cases is the generalization relationship. The concept of generalization, and you must have experienced by now that this basic concept of generalization, specialization or hierarchy is repeatedly occurring in the OOAD scenarios. So, it works in the same way as it does with classes. So, there is a base case A, there is a sub use case. Here we use the terminology sub use case B. So, base case A is self contained, that it has everything that it needs for the invocation, but the sub case B needs A, because what it does as in class associated generalization, specialization or inheritance, the sub use case inherits all the functionalities of the base case A, and after inheritance. So, this is similar to this. So, it inherits, the sub use case inherits the behavior of A, the base case, but it is allowed to override and extend it. Override means that once a use case has been inherited, it has different behavior, it has different possible operations that the use case may invoke. The sub case B may use these operations as it is from A, or it may want to redefine the behavior of the operation. If it redefines the behavior of the operation, this basically means redefine, then we say it has overridden the particular operation from the base use case. Or it may want to extend it, which means that it will first execute the operation as in the base use case, and then it will add something more. So, the possibilities are use as it is, that is just inherit, override, that is use the same name of the operation, but have a different functionality, or extend, that is first use what you have inherited and then you do something more. These are all the possibilities. So, in overall the B inherits all the relations of A, the whole functionality of A. And in this context, it is possible that we can have some use case which is abstract. So, if a use case is abstract, we will normally write within the use case that this is an abstract use case. What is the meaning of the abstract use case is that this is a scenario of action which will never take place in the real world, but this is being put in place more for the modeling purpose to unify a number of different possible use cases that can happen. And like in abstract classes, this is also a regular functionality of use case. So, as an example, let us say I have an authentication system. So, I have a use case for authentication which does variety of authentication like password based authentication, maybe SMS, OTP based authentication and so on. And I want to define another use case, authentication by fingerprint, which specializes from the authentication user case. So, what it does, it inherits all the different algorithms and operations that the authentication use case has, but in addition it will include some fingerprint matching strategies in the authentication in this use case, and that is how the authentication use case will get specialized in the authentication by fingerprint. Talking about LMS example, if we think of a use case to export executive leave and another use case as exporting manager leave, then we will have again a generalization specialization relationship, this being the base. If I want to export the manager leave, certainly I will do everything that is required for exporting the leave of an executive, which is the base case, but in addition I will need to possibly do some more export of the data in terms of the different employees who report to this manager and their availability during the leave of the manager. So, this will typically have that when I extend, I inherit all the functionalities of the export executive leave use case and then execute them and do something more on top of that. In LMS, we could also think of abstract use cases. For example, we can say that we have different use cases like request is a use case, then approve is a use case, then avail is a use case and so on. I can say that I have a use case act on leave, which is an abstract, and we can say these basically are all specialization of this particular act on leave use case. So, what does the act on leave use case perceived as? It is some action on the leave. So, this will have the basic functionality of checking out on the leave record, maintaining in the leave store and so on, which is something which all of these leave use cases will need for its own invocation, for its own implementation. So, instead of that all those leave store management related stuff being implemented as a part of all of these specific use cases, we could club them together and conceive of an abstract use case like acting on leave. Now, why is this abstract? Because by itself just the functionality of the leave being maintained on the leave database, on the leave records that being accounted and so on, just by itself is not a stated functionality or a perceived functionality if we look into the leave management system. So, but this will come out through the discussion and analysis of the LMS specification, that such abstractions could actually help the system get organized in a better manner. Besides the relationships amongst use cases, there could be some more relationships, like there could be a generalization relationship between actors. That is, we can think that actors like an executive, the example is the best way to look at. Executive is an actor, lead is an actor, and we have already in terms of identifying classes, we observed this, that lead as an employee can do anything that executive as an employee can do, but lead can do something more. So, we again have a base. So, this is a base actor and this is the sub actor or the specialized actor who inherits all the functions of what the executive actor can do, but lead actor can do something more, and in turn that could be specialized further in terms of the manager actor. So, what happens is often this is very useful, as we will see that if we have two actors, one is here and one is here, and suppose we have 4 different use cases, and this actor can use these 2 and this actor can use say these 4. Instead, so basically it means that the actor A1 and actor A2 can do anything that A1 can do. Then it may be more explicit to model this separately, that I say this is A1, this is A2, and there is a specialization of A2 from A1, and of the different use cases I will associate these 2 with A1 and only these 2 with A2. I actually do not draw these associations, because since A2 is a A1, it is implicit that all these use cases will also be associated with A2. That often simplifies the clutter and simplifies the model much better, and give a clarity in terms of the use case diagram. So, to summarize this module, here we have continued our discussion on the use case diagram, and in addition to the actors and use cases, we have now seen that there could be relationships between use cases, and in specific we have talked about include, extend and generalization relationship between use cases, and we have also seen examples of the LMS system. We will continue this discussion in the next module as well, where we will try to explore and consolidate the use case diagram for the LMS system.